This is part 1 of the notes for Thursday, November 19th. We'll be talking about isosceles and equilateral triangles today. Part 1 is the properties of isosceles triangles. If you've already been on Canvas, you saw at the beginning of the module before the notes, I had 2 links to some GeoGebra. It's an online program. Hopefully you went on there and you played with it just a little bit, the one with isosceles triangles. And you may have already discovered what some of the really important properties are for isosceles triangles. First of all, I want to get some vocabulary out of the way. We've already defined isosceles triangles as a triangle having 2 sides of the triangle equal in length, and so we call those legs, L-E-G, and they are marked with the hash marks. On this particular triangle, they are the sides on the left and the right. The third side, the one that it happens to be sitting on at the time, is called the base, though I will tell you it's going to be called the base whether your triangle is sitting on that side or not. The 2 equal sides are legs. The third side is called the base. The names for the angles, they are labeled there. The vertex angle is the angle between the 2 legs. And the base angles are on the either side, the left and right, of the base. When your triangle is sitting on the base angles are the ones at the bottom. One thing I do want to make sure that you understand is that a triangle, an isosceles triangle, does not necessarily have to be sitting on that base. I've drawn another one. I turned it sideways. The easiest thing to do when you're identifying the parts is to identify the legs first. The legs are the sides that are equal in measure. So I've written down leg next to either one of those 2. That means the vertex angle is the angle between the legs. And meeting the base is the third side. And the base angles are on either side of it. The reason it's important that we know the terminology is because this terminology is used in the next theorem that we're going to be looking at. If you played with the GeoGebra on Canvas, you probably already discovered, I'm going to see if I can get this thing to start. It's not going to start for me. It was working just fine a few minutes ago. Well, go ahead and play with it on your own on Canvas in the module. I think what you found, if you were watching these sides, you would watch and see that those legs would end up being the same measure. And as they got larger or as they got smaller, the base angles would also get larger and smaller. But the base angles would always end up being the same measure. I figured out what happened. I can't run the GeoGebra while I have my pen going. And if you'll watch as I drag one of these sides, the legs, even though the base is getting bigger, the legs are the same size. They never change. Doesn't matter if I change the angle. I can move that vertex angle as long as the 2 legs stay the same. If you notice the angles down at the bottom, B and C, angle B and C also stay equal. Doesn't matter how tall and skinny I make the triangle, or if I make it very short, the 2 legs remain the same length, and those 2 base angles will always be equal. And folks, that is what our theorem says. Theorem 4.3 says, it's the isosceles triangle theorem. It says if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. In other words, if the legs are congruent, then the base angles are congruent. The converse of that theorem, remember, a converse exchanges the hypotenuse and the hypothesis and the conclusion. Sorry about that. The converse says if two angles are congruent, then the sides opposite those angles are congruent. And that's what you discovered in looking at that GeoGebra exercise. So let's use these theorems. I have 3 examples. We're going to use them. And what it's going to do, it's going to shortcut for us using the sum of the angles of a triangle. So we don't have to use that 180 degrees anymore. If we can, or we won't use it to find all 3 angles. We will use it. We just won't have to use it one at a time to find all 3 angles. All right, so here's the first one. We have triangle DEF, and we're going to find the measure of angle F. Okay, first of all, we've got a 22-degree angle, but we don't have any other angle. So since I know that the angles in a triangle add up to be 180 by the triangle angle sum theorem, I'm going to do a subtraction. And that means I have 158 degrees left for the 2 base angles. Total. And since this is an isosceles triangle, the 2 legs are congruent, by theorem 4-3, it says if those 2 legs are congruent, then the angles opposite those legs, that's angle D and angle F, are congruent. Well, if they're the same measure, then they are equal. So those 2 angles together equal 158, which means each one separately is 79 degrees. That is the measure of angle F. Just gives us a little different way to look at these. All right, let's take a look at the next one. This time we have triangle JGH. And we are asked to find the measure of angle G. All right, first of all, let's identify the parts, okay? Here's a leg. That's GH. And JH is also a leg. So that means the base is the 3rd side. So angle J and angle G are my base angles. According to the theorem, if the 2 legs are congruent, then the angles opposite those legs are congruent. So that means the 3x and the x plus 44 are the same measure. Since they're the same measure, we can set them equal to each other, and we can solve for x. X equals 22 degrees. Very convenient theorem. All right, last one. Let's see how it works here. We're asked to find the measure of angle N. Angle N is up here at the top. First of all, identify your legs. So here's a leg, here's a leg. That means that 3rd side is the base. And since the 2 legs are congruent, the angles opposite those legs are congruent. That's angle N and angle P. And since the legs are, or those angles are congruent, we can set them equal to each other. If I subtract 8y from both sides of that equation to solve it, I get negative 2y equals negative 16. Divide both sides by negative 2y equals 8. I haven't answered the question yet, but I will in just a moment. The measure of angle N is equal to 6y. That would be 6 times 8, or 48 degrees. These problems are a little shorter than the ones you did yesterday. Remember, anytime we're introducing a new idea, they become just a little bit more straightforward because we need to learn the theorem, need to learn how to use the theorem. All right, now that you've seen how isosceles triangles work, let's move on to the equilateral. Let's move on to part 2.